Hey, and welcome to another edition of Solve My Math Homeworks Video Solutions. So today, we're going to solve a quadratic function, but we're not going to factor. We're not going to use the formula. We are going to use a process called completing the square. So let's get started. All right, so when we look at this, we see a few things that look different. Now, we know that it's a quadratic. We got the highest power of 2, so it's definitely a quadratic, but it's not in standard form. There's a few things that look off. Normally, our quadratics, remember, they have to equal 0. So let's remember, quadratic in standard form, the quadratic term ax squared, then the linear term bx, then the constant term c, all get set equal to 0. So this is how we're supposed to see it, and this is what we're going to do. We're going to put it in this form first. Okay, so let's get rid of this. And it's fairly easy. It doesn't equal 0. We want it to. So what's causing it to not equal 0? Well, the fact that it equals 2. It equals 2, so we're going to get rid of 2. How do you get rid of 2? You subtract it. Anything you do to the one side of the equation, you have to do to the other side of the equation. Okay, so we've got x squared minus 2x. 1 minus 2 is negative 1. And now it equals 0. Now remember, a lot of you might be thinking, all right, factors of negative 1 that add up to negative 2. Well, first of all, they don't exist. And second of all, we were asked to do completing the square. So completing the square is a process. It's not a formula. I find it easier to remember. So what we're going to do is talk about why this process came to be. So completing the square takes something that's not a perfect square trinomial and it makes it one so that it's easy to factor. So let's take the little Wayback Machine here and remember what I'm talking about when I say perfect square trinomial. Let's say, now this is unrelated to the problem, let's say we have this binomial x plus 3 and we square it. All right, well that's two factors of x plus 3. So that's x plus 3 times another quantity of x plus 3. Okay, so you could FOIL, or you could just know your patterns for squaring a binomial. Either way, you're going to get your first terms be x squared, your outer will be 3x, your inner will be 3x, doubling that and making it 6x, and then your last will be 3 times 3 is 9. Okay, so this is a perfect square trinomial. And it's a perfect square trinomial, and you'll notice the first term, perfect square. X squared is a perfect square. 9 is a perfect square. Okay, it has to be positive to be a perfect square. And this linear term, there is a relationship between this. This linear term, 6, or actually the coefficient of the linear term, 6, is exactly twice as much as the square root of 9. All right, so that's how you're going to know that it's a perfect square trinomial. And we're going to use this relationship, especially the fact that the coefficient on the linear term is twice as much as this when we do this process. Okay, so we've now put it in standard form. Let's get started. All right, so here we are. We have x squared minus 2x minus 1 equals 0. Well, we said we want a perfect square trinomial. This negative 1 is not a perfect square, so I'm never going to have a perfect square trinomial as long as that's there. So let's get rid of it. Okay, so we're just going to add 1 to both sides. Add 1, add 1. So we get x squared minus 2x. Now, technically we have nothing here, but I like to leave a placeholder. So plus something to be named later equals 1. Okay, that's something to be named later is our new c term that is actually going to make this a perfect square trinomial. So let's talk about what the new c term will be. Okay, so you'll remember that we said that this coefficient on the linear term was exactly twice as much as the square root here. So that means we're going to take this linear term, which is b, by the way, and we are going to divide it by 2, and we are going to square it and add it to both sides. Okay, so half of b, and now this is the one time in your life. I know b is negative 2, but remember, when we take half of it, we're going to square it. Anytime you square something, you get a positive. This is one of the very few times in your life you can ignore the negative. So half of 2, or half of negative 2, is going to be 1, and we are going to square that and add it to both sides. So let's go ahead and put that in right now. We're going to take half the b term. Half of b is 1. We're going to square it. We're going to add it to both sides. Okay, anything I do to one side, I do to the other. Okay, that's our new c term. Now let's clean this up a bit. So x squared minus 2x plus 1 squared is really 1. Equals 1 plus 1 squared, so it's really 1 plus 1, so that's 2. Okay, so here we go. We're now rocking and rolling. So what we're going to do, the whole reason for doing the whole new C term and all that stuff was so that this would be a perfect square trinomial. So let's see. Perfect square x squared, sure. Perfect square 1, sure, 1's a perfect square. And this is exactly twice as much as the square root here. Okay, so that means I could write this left side in factored form, like the square of a binomial. So that's what I'm going to do. Let's figure out what that is. It's going to be, let's see, x factors of positive 1 that add up to negative 2 are going to be x minus 1, x minus 1. Now, you'll notice in the future, you won't have to think this much about it. You'll just say, I know it's from x squared, I'm going to get x. Whatever I squared here, so I had 1 squared, that's what's going to go here, and the sign from here is going to come down. So you'll get used to doing that. All right, so now I have x minus 1, the quantity x minus 1 squared equals 2. So I want to solve for x. That's always my point here. All right, but x is protected. It's within these parentheses, protected by that little square there. So I have to get into it. The only way I can do that is get rid of the square. So the opposite of a square, or opposite of squaring, is square rooting. So we're going to do that to both sides. So opposite of squaring is square rooting, so it literally negates the square when you take the square root of a square. So all we're left with is what it's inside. Okay, so x minus 1, no longer do you have a need for parentheses. Okay, equals. Now, remember, there's a positive and a negative to every square root. Actually, every square root except for 0. But when you have this square root of 2, you need to remember to bring down positive and negative solutions. So you bring down that positive negative symbol. Okay, so now we actually can solve this. X is still not isolated. It's not by itself. So it still has a negative 1. So we add 1 to get rid of the negative 1. So then we're left with x equals 1 plus or minus the square root of 2. That's actually our solution. We're all done and good. I just want you to know that this does represent two solutions. Remember, most quadratics have two solutions, those two x-intercepts on the graph. So this represents the solution 1 plus the square root of 2 and 1 minus the square root of 2. Those are both of your solutions. You don't need to write them out like this. I just wanted you to know what this symbol really means. It really does represent two solutions. Okay, if you submitted this problem, I hope that helped. If you have questions, leave it in the comments section. Be sure to subscribe to our YouTube page so I can solve your homework problem next. Thanks for watching.